But first of all, welcome. Welcome, ladies and gentlemen, to the Columbia Memorial Space Center. So let me begin by introducing, and I have to apologize because I am terrible at name pronunciation, and I've always mangled it. Dino Toigo?
Yeah.
How do you prefer?
My nickname is Dino. My real name is Alexander. And my last name is Toigo.
Toigo. Okay.
Toigo. It's Italian. And it comes from the northern part of Italy, north of Venice.
Tell me a little bit about, when we don't always get to choose our careers, but there's certain things that kind of point us in that direction. Was there one particular thing that kind of directed you or made you feel like engineering or aerospace was where you're going to end up?
When I was younger, I had no idea about going to college and becoming, study engineering or business management of any of those courses. I was interested in becoming a machinist. And I took my high school education to learn how to become a machinist, and I graduated from high school in that type of a course. But after I was working in a machine shop for a couple of years, I decided that I wanted to be a tool and die maker, and they were making a lot more money than for running a drill press and a lathe and stuff like that. But I got stopped. A good friend of mine, who was like my second father, he was a doctor, a family doctor, and he told me, why don't you go back to school and go to college? And so he talked me into going back to prep school. I went back to prep school for a couple of years, and then I ended up going to the University of Miami and School of Engineering down in Miami. Fortunately, while I was in school, in high school, I used to play the French horn in the band. And when I got to the University of Miami, I tried out for the band, and I ended up becoming a member of the University of Miami marching band. And my kid brother, who was going to George Washington University, who's 2 years younger than I am, he decided to come down along with me, and he played saxophone. So the two of us were a member of this Band of the Hour, which is called the University of Miami Band of the Hour. So I spent 4 years there getting my degree in civil engineering.
We were talking before the session here today about those early days, and it was in '52 that started you right off on some of the best and earliest aircraft programs. Can you speak a little bit about some of those early programs that you were involved in?
Well, when I hired in at North American, I got into the stress group, and I worked for in the landing gear group. And we did a lot of work in running numbers and working on the tanks that are attached to the, I forget which airplane it was. I think the first one I was working on was the F-86D. And we spent about, maybe a year or two in that group working on that program. Then from there, we messed around with the F-100 and a couple of different models of the F-100. And I got on the F-8, I think it was before the B-70, I went on the 108, I think it was. And then they canceled that program, and I ended up on a B-70. And when they started flying the first model, I ended up leaving there and going to Downey in 1964.
Yeah, a lot of the folks, myself included, when they canceled the XB-70 program, we ended up coming over here because the staffing was going on for the Apollo. Yeah. Those early days of aircraft, what was it like working in an aircraft plant?
You couldn't do the things you can do today. you came in, you sat at your desk, you did your job, you got up, and then you went home in the evening.
Do you remember something we called the bullpens?
The what?
The bullpen?
The bullpen?
Yeah.
Yeah.
The bullpen was in most of the early aircraft company configurations, they would have just these huge office areas, and the desks were side by side, and there were no partitions. This was before the world of partitions, and there was a lot of advantage to it because I could sit at my desk,
Yeah.
and if I wanted to talk to Pete, and Pete was up there, I could just look up and see if Pete was there. I didn't have to go call him or find him. Could even wave to him. Hey, Pete, come on down, let's talk. But of course, then, as time would have it, we learned that, we needed privacy, and up went the walls.
But it really wasn't that bad, Jerry, too much, because all the desks were all in a row, and the supervisor was always at the front end, and he always was facing us, okay? And if you could see him, you were lucky, because the smoke in that room was filled so thick. And I know because I used to smoke cigars, and if there was one cigar smoker, there must have been 50.
Oh,
and
yeah.
then everybody was smoking cigarettes, and it was so you couldn't see that glass door behind you. It was so crowded.
I think I mentally blocked that out, but you're right. There was a haze.
And it was really smoky. Nobody complained, though.
So let's move forward to the Apollo program. Actually, I think you mentioned to me that when you came over here, you actually started on the Saturn program.
I was on the Saturn II, the second stage booster for the Apollo. And I went, they had the stress group was in Downey, along with the Apollo stress group was in I think they were all not on the same floor, I don't remember. But anyhow, they had a mock-up up there, too, of a part of a stage. But after a while, they started building the Saturn II test vehicle down in Seal Beach. And so people used to go back and forth to help out and support down there. And I ended up being asked if I wanted to go down there. And I thought it'd be nice for a change. So I went down there, and I should have stayed in Downey because it was really a lot of work. But eventually, we picked up two more of my cohorts that came down with me, and they were two real good stress guys. One by the name of Joe Nepper, and another one was Mike Strecker. And Joe was working on the tanks in LAD, the single tank sheets of the tank, and Mike and I were working on the overall stages where they were welding them and putting them together. So we got nicknamed the Three Musketeers, but and we ended up doing a pretty good job, I think.
Now, one of the events that occurred down in Seal Beach during the Saturn S2 program was an unfortunate test failure, hydrostatic testing of the tank. Can you talk about that?
Well, they had a S2 test that they filled with water, but I think the director of the site was there running a set, running a test. They filled the tank with water, and I think they got to 99.8%.
Really? And how big were these tanks?
30 feet, 33 feet in diameter. The tank is 60 feet long.
Wow, that's a lot of gallons of
It
water.
was filled with water.
Yeah.
And it let go, and it was all kinds of water all over the place. But they called it a success. but I got there the day after that.
After the mess.
After the mess, yeah.
Yeah, that's about equivalent to if any of you had one of these portable swimming pools in your backyard that are about 3-4 foot high, maybe 10, 15 feet across.
Yeah.
That's about maybe 1/5 of the size of the concentration of this tank. So 5 of those and the sides all letting go at the same time in that deluge of water. When you drive Seal Beach Boulevard down at Westminster, there's a tall building at the Weapon Naval Air Station, and that tall building is the
Yeah.
building that Dino was talking about.
Yeah, the LH2 tank is roughly 33 feet in diameter, and there's 5 rings. There are 4 panels that make up a ring. They're roughly 8 feet tall, and the tank has 4 vertical welds to make it the cylinder, and then there are 5 sections that make it that gets the 33-foot diameter weld, which is about 100 feet of weld around there, and then it gets welded to another frame that attaches the common bulkhead and the LOX tank, which is the liquid oxygen that goes in there. And so there's a forward bulkhead on top, and I think the overall height of everything is about 81 feet. So, but the tank itself is about 60 feet because each panel about 8 feet plus the short panel and the and the forward bulkhead. So it's pretty big.
Dino's mentioned here a couple times he worked in the stress group. My experience is that every group I worked in was a stress group at the Apollo program. But can you talk a little bit about what was a stress group about? What did you do in the stress group?
Well, we analyze the structure.
Okay.
I always say the stress man decides if the hardware is strong enough to be able to do the job it's supposed to be designed to, and that makes it real easy and deal. That structure was we filled that tank. I think when we pressurized the tank out in the site, we put like 33 psi, 33 to 36 pounds of pressure inside that tank, and so you get this big hoop stress in there. It blows up like a balloon. Mm-hmm. So, and then afterwards, after they test the vehicle, they take it back and they X-ray it, and they penetrate inspect it, and it's not so much the skin panels, but the welds that go around, because each weld that after it's made gets X-rayed and penetrate inspected. In the early days, when we made the welds, when we did the welding on the tanks, the doors were open, and fellows that were doing the welding were smoking their cigarettes or cigars, and all the welds, when you looked at the X-rays, were full of porosity or oxides or stuff like that, and we had to go in there and determine which ones had to be cleaned out or grooved out or patched up again. They had to went in and hand welded it, and they had a machine that I'm getting away. They had a machine that when they put the 2 stages together, they would make the complete weld all the way around, and then they would come by and do a second pass because it would push the stuff back into the back a little bit and make a cover pass and complete the weld. Then they would go in and do the X-raying, and they would penetrate and inspect the outside and the inside of the tank, and then the engineers would determine which one, where they would go in and start to grind away and fix it up. It got to a point sometimes when it looked like the whole tank was being grooved out and re-welded, and it ended up having a Coke bottle effect because the welds would start to shrink in when they put it all in there. So after after a couple of times, we had a hard time trying to buy a lot of that stuff off. But we finally ended up with all those hand welds. We would have the fellow doing the welding run another pass with the welding machine, go across there to melt all that weld to make it work out real good. And it came out pretty good. But it got to a point over a period of time with the doors being open, and it was getting really too bad. I wrote a disposition one time to make a 360-degree cut across the 33-foot diameter and separate it, clean all the weld out, put it back together again, and re-weld it.
Oh,
and
my
that
God.
saved a lot of time over a period of days, because each time you weld it and clean it and weld it, you'd have to go back and X-ray it, penetrate inspect it, and it was always a delay in the schedule. So this way, by separating the tank and re-welding it, you were able to clean it and do a better job. And they try to close the doors, stop the people from smoking. There's only one or two people in the shop, and it started to become much better. Over a period of time, they finally made a white room where the whole building was
Clean room.
air conditioned and everything else, and the welds came out perfect. But we had a lot of problems with those welds. At one point, the tank had bowed in so bad, they called a guy from LAD, Los Angeles Division. We called him Planishing Pete, because he came over and said that the way to get the bend out is like you take the crease out of a fender in a car. You take a hammer and you ball peen it around there and push it. Well, he came with his little hammer and started pushing. And one time I walked in the building and you heard this bell ringing, and he had a big sledgehammer pounding on the on the thing. And so we got worried because of the skin stringers that come down, that you have to tie the two sections together. The inside of the shell is all stringers, every so many inches apart. And then after the weld's made, they got a section that comes through, and you tie everything together. And the tank at that point had a little bit of a bow, so our director had to go to NASA and convince them that we're going to buy this one off, and was able to go and fix it, and they accepted it. But we never did. We sent Planishing Pete back to LAT. So,
Planishing Pete.
yeah. But
We had talked earlier before the session about some of your travel experiences with Saturn down at Mississippi.
yeah.
Can you specifically? I'd like
Yeah.
you to mention
Yeah,
the sign-off paper.
We used to follow the tank down, and a lot of times I had to leave to go down and spend a couple of weeks with the tank down there while they did the test firing down there. And then when they did the test firing down there, they went back and checked the wells to see if they had any problem and stuff like that. And my particular job down there was to support the project people and also the inspection people that would make all kinds of dispositions to do this and do that, and we would look at their disposition or change it or make a different type of a disposition to see that it would be carried out. And the piece of paper would be signed by inspection, engineering, and NASA. It was a NASA on the site, and I didn't know this, but I was signing all these papers because I was qualified by my people back at Downey. They had listed a notebook with the names of all the people who were qualified to sign paperwork, and in Downey, in Seal Beach, in Huntsville, in Mississippi Test Site, and at the Cape. So I had a couple dozen pieces of paper signed, and one day I got called into the director's office, and they asked whose name is on that piece of paper. I said, mine. They said, you're not supposed to sign that piece of paper. I said, why? I said, I'm the engineer. I can sign it. I'm cleared to sign it. They said, no, the site director signs all the engineering that's on there. And he said he comes in at 2 o'clock in the morning or 2 o'clock in the afternoon, whatever it is. He signs it. I said, I don't know why he's coming in to sign a piece of paper that I wrote, because he don't know what the hell's going on. Okay? So I said to him, I said, does he know stress? He's a power man. He knew all about the engines and everything else. So I made a note and told him, and I told the site director and head of inspection that he can sign the paper anytime he wants to after my signature is on there. Okay? And then I got my notebook. And I pulled out my notebook and I showed him on there that, hey, here's my name and my two buddies, and they had the power guys on there, the electrical, and all these names were signed by NASA here that gave us deal on the site. So I said, let me see your paper. So they showed me their notebook. It was just the names made on the site. And I told them, you guys are not authorized to sign anything, okay? And so as long as Mike or Joe or myself were down there, they never bothered us at all. We were able to sign all the paperwork, and he was really happy. Dick Schwartz, that's the guy's name. He was really happy that he didn't have to come in at 2 o'clock in the morning.
Yes.
And we're good friends. We're really good friends.
We're trying to make. Yeah. I'm trying to see if I can get Dick to come in and do one of these interviews later this year, for the benefit of our audience. This is one of the phenomenons of leadership and management. The fact that what typically happens in organizations are you have people like Dino who are experts in their field, and they've learned all the lessons. They know
not really
all the
an
information.
Expert, but I'm
an expert, and these are the people that are responsible and do make those critical decisions. And in many cases, the signatories at these upper levels are merely rubber stamping the people who really know what's going on. And I know when I first got into management, the first thing I had to do was to understand and accept the fact that there's no way that you as a manager can know everything. And it's the people who you rely on to do the work that are the most important. And in this case, they are the pioneers that we're talking about, the ones that can make that assessment and do that job.
Yeah. I have to say on Apollo 8, I think, which was the first astronaut flight, we had a tank that was it was I think it identified as STS-3, we called it, and they were worried about all the stuff we bought on MRs. You could and engineering and NASA were really concerned about it. So they brought in the director from the LED division, and I used to be my boss over there, Dick Schleicher. He was in charge of the structures department over at the Los Angeles division. And he came over, and he was going to go over all the paperwork to see all these 5, 6 areas of all these welding and check everything. And he didn't know nothing about anything. But anyway, we sat down like you and I at this table, pulled out all the books, and he was a big cigar smoker. He had these big cigars he was smoking. He gave me one, okay? And we sat there, and he looked at it. He finally agreed everything was okay. But I tell you, I was concerned on one of the welds that we had made. We were inside the tank, and the thickness of the welds, about 5/16 of an inch thick. There's a weld end. There's a section of thickness because the skins are less than 30,000. They're thin, and to allow the weld to stick together. And we grooved out a deal, real long groove and fairly deep. And when the Apollo launched and made the flight successful, we were happy because we were worried about that groove out, you know. Because, see, we didn't lose a tank. All the tanks we built, they all flew. We never had a problem with any of them.
Yeah, Apollo 8 was one of the.
And the only one that we lost was the other test and dynamic one at Mississippi test site, where over the holiday they were changing crews and somebody forgot to open up a valve and they blew the tank all over the field, okay? All into smithereens. So we lost that tank.
Yeah.
But that was a test tank, so.
In terms of the Apollo program, and specifically getting into the Apollo missions, what was your involvement on the Apollo? Were you still on the Saturn, or did you have direct work that you were doing on Apollo?
We were just supporting the operation. If they ran into problems, we would be there to help, support it from the structure standpoint. Because
Okay.
every time there was a problem, there always had to be a piece of paper written. So whoever was the quality person or the engineer, the NASA one, if you were electrical, mechanical, structural, or whatever it was, he was the guy that took care of that particular portion.
Okay.
Yeah.
Okay, I'd like to shift gears a little bit here and talk about in any program, and of course with all of the sites that you were working at, there were different people that you had to work with on a daily basis. Does any one individual stand out in your experiences that kind of as a mentor to you in terms of your career?
On the whole,
On the whole thing.
on the Apollo or everything.
On everything.
One fella by the name of Don Emerald.
Please speak about Don.
I worked with Don Emerald when he was over at LAD, Los Angeles Division, and he always was able to help me out whenever I ran into all kinds of problems. Okay, and I ran into him when he left the Los Angeles Division, went to work for another company, and then he came back over on the shuttle program, and he became chief engineer or something on a program, and he was really a great help to me also. And I got to tell you, Jerry, you were pretty good too.
Thank you, Dino. I appreciate that. Yeah, Don was a fabulous guy to work with, and we had, as I mentioned earlier before this interview, we had the opportunity to get some oral history collected from Don before he passed away, and we are planning on doing some. I'm not sure how I'm going to do it yet, but we want to do some post interviews with people like yourself and others who knew Don that could share some of those memories of just what made them so important.
But I'm going to backtrack a minute here
Please.
and tell you a story about the Saturn program a little bit, okay?
Okay.
There were a couple of us. There was a small group at Seal Beach. We used to start work at 8 o'clock in the morning. And I never used to get home at night until sometimes at 9, 10 o'clock at night. And I would walk in the front door, and my wife would tell me that I got a call from Seal Beach, and I got on the phone. They needed someone to come down and look at something. I got in my car, drove to 11 miles, 12 miles across the bridges to go back there, 2 o'clock in the morning, I believe, and go back home again. And then sometimes we'd have a problem at home with the children or something. I'd have to be 5 minutes late at work, and there was manufacturing looking at their watch and say, "Oh, banker's hours."
Yeah, the old banker's hours.
But those were long hours, and we could not fill our time card to put in the total amount of hours we worked, which they never said anything about that.
You know, the whole idea of the Apollo program and what has been presented in media and books and so forth, it was a wonderful program.
Yeah.
People need to understand, though, that the cost of that program went far beyond the dollars and cents that the government invested in it and the contractors and so forth. There were a lot of personal costs, and as you've just described, the hours that it took away from family. Of course, we had the Apollo 1 crew, which paid the ultimate price for that program. For me personally, it was an accident that occurred right here on site, and I lost vision in one eye because of the program. That was my contribution, I guess. Is there something besides just the family cost that comes to mind for you in terms of?
I'll tell you, I was at the Cape on the first, I think it was, I don't know, first flight that they were going to fly the astronauts or something. And it was about 6 o'clock, 5:30, 6 o'clock. I was leaving, going through the site, and I decided to take a couple minutes and take a sidetrack and go over where the astronauts were in their capsule, and they were going to have a test where they were going to try to get out of the capsule and have an escape deal to go. So I started to drive around, and I couldn't find the facility. I couldn't find the building where they were doing the testing. So I skipped it and drove through the whole site, came on home. I got to my apartment in Cocoa Beach, got on the phone. I called my wife. I turned the TV on and said, "Oh, there's been an accident at the Cape." And my wife had the same station that I had on, and I was right there on the site when the three astronauts, Grissom, Shapey, and
White.
I forgot his name.
Ed White.
Ed White got burned on the stage. Man,
You were right there.
that's the thing I still remember to this day. You know, it was amazing because I was going to take the trip over to see it. I even got a tear in my eye thinking about it. Okay, but
Right on site.
I was right on site, and then after that accident happened there, the whole Cocoa Beach was quiet. Cocoa Beach was quiet. The restaurant there had all the medallions and everything else in Cocoa Beach, they had all the black banners on the deal, and we were staying at the Best Western Hotel. There were about 4 or 5 of us in there, and then they wanted to throw us out because they wanted to give the apartments to the news people.
News press.
And
yeah,
our people in Downey, no way.
good,
Yeah.
good.
But that really sticks in my mind more than anything else, you know. And then they had the big problem of redoing the windows
Yeah,
to make the windows open a different way
yeah. The
instead
hatch.
of in the but,
Well, on a different note, can you tell us a little bit about Apollo 11, the moon landing? Where were you when Apollo 11 landed, and what were your feelings about the Apollo 11 landing?
I was at home watching it.
Good.
I was. My parents were in town, I think,
Uh-huh.
and my dad is an old grouch sometimes, but he was watching the landing, and he thought it was a movie, and I said
Hollywood
no.
set.
I tried to explain to him. So the next, not the next day, but sometime while he was at home, I got into the car and we came to Downey, and I showed him the paraphernalia that they had and everything else, and he was really happy to see all that stuff. And I took him to Seal Beach where we were building the tanks to show him the stuff that I was doing down there. And finally, he still wasn't concerned, believe it, but I was watching it on TV.
Okay.
Yeah.
How'd you feel about it? I mean,
Oh,
you
I felt
like
good.
the rest of us, you know,
Yeah.
we all had
a good
contributions.
time.
Yeah.
We got to see one launch, and I felt good about that launch too. So
This is one that you were invited down
yeah,
to?
we were invited down.
Can you talk just a little bit about that trip?
Well, people, the astronauts used to come around the facility and pass out Snoopy pins, I guess they call them or something. And I was fortunate to get a Snoopy pin and get an invite to go to a trip to the Cape, okay? But Don Emerald was the fellow that helped me out on that, okay? And but anyway, I went down to the Cape, and we were able to go to a big old party that they had down there of all the different companies and people, and they had a bunch of astronauts walking around, and you got to get their signatures, see them,
Yeah.
and they had a board with your name on the board, and you got to see your name on the board. My wife got to see the name on the board too. She was happy about that, and that was a good time. You know, it was. I really enjoyed that, but it was 3:00 in the morning to go see the launch. But the second one, the first one, they canceled it, and we went back the next day and they fired it again, and I enjoyed it. At nighttime, it was like daylight, when the engines fired, you could see just like here, clear as a bell, beautiful. I enjoyed it.
They were incredible experiences to see a launch.
Yeah. But I was glad that all the work that I did on the tanks and put them all together and tested them and checked them, they all flew, and then we didn't lose any of them, and I was happy about that.
That was always a concern for all of us who worked on the program, that when we did have the Apollo 1 or any of the Apollo 13 later issues, that maybe something that we had done contributed to it. But in most cases, it was never.
We were there. I forgot to say we were there when Cunningham lifted off, when they fired the engine and shut down.
Yes.
Remember when it?
Oh, yes.
I was there.
Yeah, we can't.
We were
forget.
in the audience, but we happened to go down there on a trip, and we joined up and got to see that. But then they canceled that flight for a long time afterwards. And but I don't even remember when that was anymore. When you get my age, you forget everything.
Well, so far, we've had some wonderful stories. And, Tom, do we have some questions? Okay, so here's a question from Valerie. How many years are lost when you trace, let me see. How many years are lost when you travel to the moon? I've heard that traveling there takes a toll on you physically, and that it ages you in some ways. Okay, well, before you answer this, I'm going to say it ages those of us that built the hardware a lot more than the ones that are flying it. I guess that's part of the experience of creating space hardware. Frequently I'll mention when we put the proposal in for the Apollo program, North American Aviation was not predicted to be one of the primary contractors to win that contract. We were going up against companies like Boeing and Lockheed. North American was not that as big a company at that time, so there was some doubts as to whether or not we would win it. But in retrospect, we had a fabulous team that was led by Harrison Storms here at the Downey site, and we did. We accomplished it. We've learned so much from our space exploration in terms of man or woman in space. But just to kind of give it a perspective for you, the two things that are probably the most important in traveling in space. Going to the moon. Imagine going to the moon and spending a road trip in a Volkswagen Beetle. Now, you know how everybody knows how big a Volkswagen Beetle is. Okay, that's about the size of a command module volume internally. So we're going to put 3 of you in there, and you're going to travel on a road trip, and you're going to go for at least a week in that vehicle. There are no potty stops. There are no stops anywhere. You're going to go on a complete trip. Now, to make this a little more interesting, we're going to put you in space. So now, when we're here in this room, you've got the advantage of good old-fashioned Earth and gravity, which keeps everything where it belongs. All your internal organs, everything is right where they belong. But when you're in microgravity or zero gravity, all those organs float. So your stomach, your intestines, your heart, your liver, all of it is moving around and rearranging itself. I guess maybe the best analogy would be for, and the men, you have no idea, but those ladies who've been mothers and have had babies, and you've got that life in the womb in a water sack that's floating around. Well, that's what's happening when you're in space, floating around. So now we got the Volkswagen and we've got the microgravity. It's a challenging trip, very challenging. And plus then you've always got the factor that the contractors who built that spacecraft, we were the low bidders. Let's look at the next question. Was there an airlock area in the lunar module between the main cabin and outside before exiting the lunar module to avoid any lack of atmosphere being exposed to the inner control panels? So I'm going to try and rephrase this question. I think what you're saying is the lunar module, which was the vehicle and the spacecraft that took the astronauts down to the moon, the answer is there is no airlock, of course, but you open the door and you step right out to the ladder, to the little landing, and then the ladder, and you crawl down and you go to the moon. The only thing that I can share with you that I know about it was that when Buzz Aldrin and Neil Armstrong were in the lunar module and it landed, the question was, who was going to be the first one to go out the door and go down that ladder? Well, the door on the lunar module only swings one way. And Buzz Aldrin was over here, the door swung this way. So Neil had the access to go down first. Now, in reality, there's always a debate, and I think even Buzz mentioned some of this, but the reality was Neil was always identified as the first one to go down the ladder and go there. But back to your question, the airlock. Well, the airlock, no, there is no airlock. So everything that was internal to the lunar module would be exposed to the environment of the moon as soon as you opened the hatch. And of course, when we would design, now the lunar module was actually built by Grumman back in Bethesda on the East Coast. We didn't do much with that here on the West Coast. But the same kind of conditions prevailed. I think at two of our Apollo missions, we opened the hatch while on orbit. And so, yes, all of the internal controls, switches, and everything would have been exposed to the environment of vacuum of space. I guess from a materials and process side, what happens are materials in outer space without pressurization and the environment we have here will change very dramatically. Plastics in particular, we had to be very careful on the choice of our plastics, because plastics in space, if you do not protect them, have any of you seen a car that's maybe 10 or 15 years old that has been out in the sun, and the dashboard and all that plastic is cracked and split and dry and like elephant hide? That's what happens, only it happens within hours. It's an accelerated process of oxidation. So I hope that answers, Brian, I hope that answers your question. Oh, two more here. How much was NASA specification and how much was NAA design? That's a great one. I'll let you handle that one first.
I think, I'm not quite sure, but I think on a Saturn, I think it was all North American or Rockwell's design.
Yeah.
I think any changes, there were some changes made during when I was reading up on it, there were some changes made in the early beginning, because I remember they said that the tank was going to be only 20 smaller in size, and then they figured out that it wasn't big enough to do the job, so they came back and made it the bigger in diameter. It went from, I think, when I can remember it, they were talking about 24 feet. They went to 33 feet.
Well, the real problem with the Saturn S2 was that we didn't get the Saturn S2 contract until after the Saturn 1 and 4 stages were already awarded. And so they had already set specifications. And so whatever was left over was what we had as North American to fit into the S2.
But I don't know, Jerry. I don't know whether that initial design also included the S4 being, or the shape, you know. 'Cause I don't know what the tank is on the S4 size, but the Saturn tank initially they said was about 24, 25 feet only, compared to the new one that they changed it to 33 feet in diameter.
Let me phrase your question.
They said it wasn't strong enough to carry enough fuel to meet the requirement, because the tank had to go, 6 minutes of flight, the S2 tank.
The relationship between NASA as the customer and NAA, North American Aviation, as the contractor is very similar to what many of you may experience if you're going to remodel your kitchen at home. So you're going to remodel the kitchen, and so mother comes in and says, I want beautiful cabinets. They have to have, got to be white, they've got to have gold, I got to have places for all my dishes, and so forth and so on. That's the NASA specification. I want to go to the moon, and I want three 3 people in the command module, and I want you to bring them back safe. Okay, go make it. The contractor comes and says, okay, team, she wants this, 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 and this. But she hasn't said, what wood do we make them out of? What are the dimensions? Which ones go where? And how do we fit it into the kitchen? Where do we put the refrigerator and all that? Those are what Dino is talking about in terms of, hey, tell me what I've got to work with here. And so the process of Apollo was a give and take where, well, and probably the biggest one was NASA could not decide whether we were going to land on water or land. That's the only 2 choices you get. You're going to land on the water, you're going to land on land. Totally different designs in spacecraft, though, and considerations. So it was not up, I mean, it was up until the very 11th hour that they hadn't made their decisions. And so what we ended up doing, we designed for both. We designed a configuration that could tolerate the land or the water. We actually had a design, I don't know if you worked on that, but there was a design for the base heat shield of the Apollo to actually be crushable, so that when the parachutes would land, if it had to come on land, and this is similar to what the Soviets did with their spacecraft, if it landed, the first 8-10 inches of the base heat shield could crush and collapse and absorb impact. But as it turned out, we didn't need to do that because they went with the water. But a lot of it comes down to simply you hired the contractor to do the job. So do the job. You tell me how big this tank's going to be and where you're going to put the stuff and so forth. But one last question. What's the difference between welding steel and welding aluminum?
On the aluminum, there's only certain type of aluminum that you can weld. Not all aluminum is weldable. And I think on the S2 tank, we had one specific type, except they came along M&P one time, and I think you get a hold of Larry Korb, he'll tell you about one of the fellows decided to make it out of 70-75 aluminum, and it collapsed.
Well, I think what Jack is fishing for.
But
How many?
I don't know about steel because we never welded steel.
Anybody weld in the audience? Oh my God! I knew we were making a mistake when we got rid of shop out of public education. Okay. The difference in what Jack is pointing to is if you take 2 pieces of steel and you put them together and you take a welding torch and you take a welding rod and you start to weld it, what happens is heat on steel causes the steel to glow and to turn red. It goes from a cherry red all the way up to a white color. And what's happening is it's changing by temperature. So the brighter the color, the hotter the metal. And this is very handy when you got a welding rod because you can control by removing the heat and placing it, and that lets you control how you make these 2 pieces come together and fuse together. Now, aluminum, no color change. With aluminum, if you apply heat to it, it just keeps soaking up and soaking up and soaking up the heat, and then all of a sudden it goes, that's a puddle.
The first pass on aluminum is just the heat. Second pass is a filler.
Right.
On the aluminum jack.
That's for our engineering audience. Thank you, ladies and gentlemen, and we look forward to seeing you later.
I appreciate it. I really enjoyed it.